I'm the worst at this, okay? I'm the worst at this. Okay, so we've written our first test to return a certain null. Now what we want to do is we want to check whether this value is being set correctly or not. So we expect that actual is going to contain bar, and that's what we compare this with. Let's run this and try. Okay, so 3 tests, 2 assertions, 1 failure. Burn that basket. Yeah, exactly. Okay, so failed asserting null matches bar, because we don't have an implementation of this yet. How could we do this? Well, let's start implementing this. Let's go over to our memory driver, and let's say, okay, we'll forget what get does for right now, okay? In fact, hold on. Why don't we do 2 tests at once? No. Let's just do set. Set's fine. Okay. Let's have some kind of internal store for the value, the values that this thing caches. So we'll say something like private values is an array of stuff, and let's say something like deferred is new deferred. Remember from our promise example. And at the end, we want to return deferred get promise, because we want this API to return promises. That's just how this is going to work. Okay. How's the audio? Can you hear me? Yeah. Right. So, oh, simulated Greg. There you go. There's the sword. That's pretty weird how it's not putting you in my moderators list. That's weird. Anyway, create a new deferred, return a promise at the end. But everything that happens inside here, well, how does that work? Let's do this really simply. Let's say something like this: values, and we'll give key is value, and then this resolve. Oh goodness, deferred resolve value. Okay, let's see if this works. Kind of interested. Let's run these tests, and it works. Okay, that's interesting. So that's a very simple and a very naive implementation. Okay, that assumes that we always have the value that we want to set. But what if we change this test up a little bit? What if we say actual is yield cache set bar, and we give a generator here. Bats. Would this work? Probably not. Nope. Object does not match expected string. Okay, and that's because it's storing this whole thing in the values array, and that's not what we want. We want this little bit, this bit here. That's what we want stored in values. We want this executed, put to death, and the value that we get from it when it's dead, we want that stored in cache. So how do we do that? Well, we can do something like this. We can say, let's use coroutine, use Icicle coroutine. Okay, and we can say something like, if is callable value. So we assume it's a function that can be used as a coroutine. We can say value, in fact we can say coroutine is, oh goodness, coroutine create, and we'll just pass value straight into there. Okay, and when the coroutine value comes back, we can say something like coroutine done. Maybe this, something like this, or then. I mean, then is a good thing. Then actual value. Then we can resolve this promise, this deferred, this promise, this deferred promise. Sure. Here's deferred. Now I haven't run this exact permutation of code. I'm hoping it works. Who knows? Let's see. Okay. We'll also set the value in this values, which means we have to use key as well. And we'll copy this out. On the off chance that it's not callable, we'll just set the value directly. Does that make sense? So if it's callable, make it a coroutine, run the coroutine, and then store the value and resolve it. Else just store the value and resolve. Let's try this out. Holy moly, that works! So let's look back at our test. We support both this style, where we have a value already, and we support this style, where we're working a value out. Now, what happens if this is a very expensive process? What happens if this is a very expensive process? If not yielding BAS, obviously, but doing something in here, what if that takes a very long time? What if it's blocking? What if getting that cache value is blocking? Maybe it's a case of rendering a template. If we want to render a really complex template, like the other day we were trying to do plates, what if that takes a lot of time because it's doing lots of blocking operations, or it's trying to work out the template stuff in there and the inheritance? Yes, it works. Well, maybe instead of this, we can do something in a separate process. Let me show you what that looks like. GitHub, Icicle, concurrent. Now, by the way, I have a huge bet on with someone who, with Steven, who runs this, and I absolutely bet him I could get at least 4 people to star this in this talk. So in this show. So head on over to this page and click the star button top right. It'll be fine. It'll be great. Okay. Now this library allows us to do concurrent stuff, which looks a little like this. We're not going to use threading and we're not going to use workers. All we're going to use is this stuff here. We're going to spawn a new fork. We're going to yield something at the end of it. And then we're going to do context join to get that last value. Okay? How the star's looking. Are you starring this? Star it. Come on. You know you want to. Okay. Now, our first approach used a coroutine. Thanks, Greg. Our first approach used a coroutine, and that's fine if we want to convert just any generator sort of thing, if we want to get the last value of it. But maybe what would be even better is if we ran this in a different fork, a different process. Why not? So instead of saying coroutine create, we can say fork is fork spawn, and then we can give the callable thing in here. And then to get this value, we can just say value is yield fork join. And this will get the last value yielded from that fork and return it to us. So it'll store that in the $value array. And we can even simplify this a little bit so that we just convert this callable value to an evaluated value in a different process, and then we can store that. Let's see if this works. Our test should still pass, by the way. They totally don't. They totally don't. What have I done? What have I done wrong? Let me look at this example code. Context is fork spawn, and that yields a value, which we're yielding in here. I don't know what I've done wrong. Let me look at my example code. So is callable. I'll just copy this out. Burn those baskets, man. It's exactly the same code. What's going on? But strangely enough, the first value. So this we expect O. Oh, no, I don't know what I'm doing wrong here. I don't know what I'm doing wrong here. We go back to this implementation. Forking fork. Callable. Does this have to happen inside a coroutine? Oh, it totally does, you know. It totally does. Okay. It totally does, because I'm not... Okay. This fork spawn has to happen inside a coroutine because we've got a yield keyword here again. So we can say coroutine create, but we're not doing the work of whatever we're caching inside this coroutine. We're just spawning the fork and getting its value. Okay. We have to use value, and probably have to use it like that. Use it by reference. Is that what I'm doing? Oh, I've wrapped this whole thing in a coroutine. Okay, fair enough. So let's wrap this whole thing in a coroutine. Let's wrap all of this in a coroutine. Okay, is that looking better? We'll get there soon. We'll get there soon. Don't worry. Okay. Value, we also have to load the deferred in. And key. Okay. And this works now. Okay. So it didn't work before because I was yielding this fork join value, but the rest of this was just a generator. It wasn't wrapped within a coroutine. And so this promise, the promise that fork join returns, or the I don't know if it returns another coroutine or if it returns a promise, but its value wasn't being passed through Icicle. It was just being run like a normal generator. Okay, anyway, how are those stars doing? Come on, people, hit that star button. Steven needs stars. It's just Greg. It's just Greg. That's fine. Greg, you got my back. Okay, we put this all within a coroutine. If the value that's been given to the set method is a function, is callable, we assume it's something that can be evaluated by a spawn fork. We get the last value that that function returns or yields and assign that to value. So we basically replace a function with the evaluated value. Store that, resolve the deferred. Okay, I'll run the test again. I mean, they just passed, but anyway, I'll run them again. I would recommend, at the moment, because I'm doing a lot of React.js, I'd recommend Jest, which I think you can find at jest.facebook jest. Here we go. Facebook get.io Jest. That's Greg. But it may be slightly slanted towards doing a lot of React stuff. I don't know. Look through the docs and see if you like it. Okay. Now, we can set this value, but how do we get it back out? This function just says, make sure that this is null. But maybe let's change this to test value get. So, in fact, never mind. I'll just do this here. I'll just do this here. Okay. We know that this is working, but what happens if we just try a plain old get? Let's just get this value and make sure that we're using the right thing here. And then we expect this again to be baz, because by this point bar should be stored. Let's run this and see what happens. Oh, we have an error. Undefined function baz. There we go. Failed asserting that null matches baz. That's because when we get here, the get method is not actually returning anything. It's always going to return null. So our very first unit test passes, this doesn't. How do we do this? Well, now we just need to return some values. Let's make a new deferred. And what we're going to return is a promise, so we'll return deferred get promise. But what do we resolve this with? Well, we can resolve it with a value. We can say something like if is set this values key. Then we resolve it with that. Else we resolve it with null. So this will make sure that our very first test continues to pass, while our second test passes as well. That's really cool. So we have a way to set this stuff and to set it via running it via a separate process. We also have a way to get it. Now we just need to do forget. And this is pretty easy. We probably don't need to do a whole promise thing here, but just for the sake of consistency, I'm going to. So deferred is new deferred. In fact, you know what we can do? We can just say unset this values key and return promise resolved. Is that even, you can do that? Icicle promise, the namespace, promise resolved. Promise resolved. There we go. You don't even need to give it a value because it will resolve null all the time. Okay. Oh, we didn't write that test first. Okay, forget I just did that implementation. Forget I just did that. It's fine. Okay. So, set foo with a value of bar. We know this already works, so we won't even assign it to a variable. But what we will do is we'll say yield cache forget foo. So we expect this to now, and I'll have to do actual down here. I won't even do that. Can I do yield cache get here? Kdex, the slash operator is the namespace separator in PHP. So here we have a namespace separated by slashes. This is like dot in other languages. It's just a namespace separator. Okay, so we set it, we forget it, and we check whether it's set. And that should be null, right? If I can use the yield in that way. And that works! Great! Okay, so pretend we did the test and the implementation the other way around. Okay, we've done good work now. We've done an interesting implementation of an in-memory cache driver for an imaginary Icicle cache library. We can get values that have been resolved. We can set them, and we can forget them. That's pretty cool. Now I think we can get a lot more technical than this, to be fair. And I spent a lot of time learning this stuff and also embellishing on it on Saturday. And what I came up with was this library, which you can find at this link. This library is sort of an implementation of the whole thing that I've shown you now, essentially. It's got something else extra, which is interesting. It's got anti-stampede stuff. So let me show you an example of what this looks like. In fact, let me sketch the problem out, and then you can see what the solution is that I came up with. Let's make an examples thing here. Examples, server. I'm going to go slightly over in this part and then just have a shorter show, like just 2 parts. That should be fine, I hope. Okay, so require vendor autoload. And then we're using the Icicle HTTP server again, just to illustrate this point. So I'll go there and get that example. Just the server. Oh, raw. Oh, this is such a cool track. Who heard the Mario jump? Okay. Put this in, and I'll delete everything out of here because I'm not really interested in all that stuff. So let's set this up at port 8000, and we have to run the event loop, remember? Okay, and what we will do here is we'll say, we'll just get this example. Let's just get this example right here. Where's the readme? Let's just get this stuff. Okay, we'll use this cached value in a stream, a memory sink. So stream is new memory sink, yield stream end. Yield new response. Mario jump for the win. Okay. And here I'll just yield a value like bar. Why not? Because our examples are so great. Now, we should be able to run this examples server, and we should be able to go to our browser and run this. 8,000. It's given us an error. What did I do wrong? Oh, I haven't defined cache. So I'll define it out here. Nope, not memory sync. Memory driver. And we'll pass it in here. Remember, we only have to define this once. Okay, so we define the cache outside, we pass it in, and then we use it in here. Okay, seems fun. Run this. Let's try again. Here we go. Bar. Make it a little bit bigger so you can see. Here we go. Bar. So what it did was it checked for foo, saw that foo was null, and defined it in here. In fact, we can see this if we print. Whoop. Generating cache. Okay. Let's restart the server. Let's run this again and look in terminal. Generating cache. And we know it's not going to do that going forward if we refresh. It shouldn't. It's just got it here once, because every time after that, it's fetching the cache out of that internal values array, which is cool. It's doing what we expect the cache to do. There's a problem with this though, and I'll show you what this problem is. I'll restart the server and run this, and you see generating cache. Refresh this, no generating cache. So on subsequent refreshes, it just fetches the cache value, it doesn't regenerate it. But let me restart the server, and then let me run Apache Bench against it. Oh dear. It's generated it a lot of times. I was running this stuff okay afterwards, after it's generated the first batch of stuff. And it's running this slower because of me streaming stuff. But this is kind of a problem, right? It's generating the cache a lot before it starts using it out of memory. And this is a problem called stampeding. This happens when there is no cache value, and when many requests try and get that cached value and see, okay, there's no cache, let's make it, and they all start making it at the same time. That's called stampeding. And the problem moves away from not having the cached value as the slowdown of the site to how to generate that cached value. Does it do a lot of database requests? So the database gets hosed. Does it call to a lot of APIs? So you go over rate limits, or that's really slow. We don't want to have the stampeding stuff going on. So, I'll tell you what we do. Let's delete this alias, and let's delete this. And let's recreate the cache with that library that I showed you. Composer, require, async PHP, Icicle, cache. This isn't in the Icicle namespace because it's not official, and Aaron has a better implementation of it that he wants to make official, and I don't know when that's going to happen. So for the moment, I've put this on Composer so that I can use it in projects, but it's probably maybe going to be deprecated when an official Icicle cache comes along. That aside, I'm going to require it so that I can show you the difference between these two. This is taking a while to download. There we go. Not too long. Yeah. Very funny, Greg. I mustn't forget to put the chat back up. Dogpiling. There we go. Dogpiling, sure. That's a very funny name. Okay, so cache is new. Memory cache. We'll just call it like this. The only difference between before is that that was the class that we created in this project. Anyway, this is the official, the one that I made earlier, or Saturday or whatever. So if we swap that out and we start our server, unexpected TNU. What did I do? Oh. I made a syntax error. Yeah, Okay, we restart this and we refresh, we get bar, and we've got generating cache. Refresh it again, it's loading from cache. Okay, let's restart it. Let's run Apache Bench. Just once. That's pretty sweet, eh? That's pretty sweet. Okay, so why is that working? Well, in the implementation that I did, let me switch to that I spent a little bit more time on than just what I've done this evening, I made a few changes. The first is that there is an array for, this is our values array, right? Like we had in the implementation tonight. This is an array for requests to get and to set that are waiting to be resolved. And this is an array for deferreds that are busy generating those cache values. Okay. So what our get function does, let me look at the set function first because that's a little bit more interesting. What our set function does is it creates the deferred that we had before. Then it puts some executable function in the next tick of the server, the next tick of the event loop, and says, if you're busy waiting for a value to be returned, say for instance the key is foo, and another deferred comes along and says set foo to something at the same time, then this will say, if you're not the deferred that is busy generating a value, and you're setting the same key, you should wait. This wait function, let's have a look what it does over here. It creates a default array if there isn't one, but then it says add to this array of the type of the key of value you want to set, this deferred. Okay, this promise of a future value. Then it runs the coroutine to create a fork, just like we had in our example code tonight. And it says, okay, if nothing else is trying to generate the cache for this key, set this thing as the coroutine that is trying to generate the cache for this key. Do fork spawning like we had before. Then set the evaluated value to the cache and say, okay, we're not busy working this out anymore. So future things that want to call set on the same key, at this point, they can start setting again. Then fetch everything that was waiting for that value. Set all of that to resolve all of those to the value that we worked out here. And finally, resolve the value for this call to set. So remember we say value is equal to yield cache set. We get the value back that was evaluated, right? So resolve that at the end. That's interesting. What about get? Get's kind of similar. Again, we put this in the next tick of the event loop. We say if busy, add yourself to the wait array. Otherwise, resolve with the value that is cached for this. And that value function is down here. It just says if set, then return that, otherwise return null. That's a pretty simple one. But if it's busy being generated, wait for it. Otherwise, resolve to the value that's stored there. And forget's kind of whatever. But this gives us the ability, this waiting queue and this busy queue gives us the ability to prevent stampeding or dogpiling, because only one thing is setting the value at a time. And subsequent calls to set while that value is being generated, they wait. And calls to get wait if that value is busy being generated. Which means if you start generating, but it's not fully generated yet, you can still call gets on that, and they will still wait until the value is there, and they'll resolve with that. So it's exactly the same API as we had before, but I'm doing something interesting in this test as well. So here I'm saying in this example code, if you go to async.php/icicle-cache, and you go to the examples there, you'll see my example code's doing something interesting. It's making HTTP requests to icicle.io, and if this cache wasn't working, and I ran Apache Bench at like 150 concurrency, I don't know if it's the case with Icicle because I assume it's based on Icicle, but many sites would just fall over at that point if this cache wasn't working. But because of our anti-stampeding, only the first request is made, and everything subsequent to that is loaded from cache, which is pretty sweet. So this is an interesting thing. And it's all made possible by the ability to think in promises, to think in values that will happen at a later point, and to write code that works with that, that doesn't depend on a very deeply nested callback structure, but that we can use promises for. Now, just to clear up, there are two things that I want to clear up on this. The first is the difference between deferred and promise. Promise is a very set specification. It's not been defined or ratified in PHP yet, but there is a very good implementation of the spec. In fact, a very good spec of this. Promise A+. And Icicle is compliant with this. React PHP has an implementation of promises that is compliant with this. I'm not sure about AMPHP because I haven't been into this part of it yet. But this is very clear on how promises work or not. See, there's the then function, and it talks about errors at some point in here. And there are some very good JavaScript implementations of this Promise A+ spec. And so promises, the way that they're defined to work, a promise can be resolved or it can be rejected. And once it is resolved or rejected, it can't be re-resolved to something else or re-rejected as something else. Once it's resolved, or once it's rejected, and that's it. It's a very kind of immutable state of thinking about it. And deferred is a way for us to act on these things internally. So deferred gives us a way to be able to resolve these or reject these things in a very friendly manner. We can write our asynchronous code, we can use timers, we can use other asynchronous APIs or processes and forks and blocking stuff elsewhere. We can use these things and then we can say, okay, if this were a promise at this point, we would resolve it with a value or we would reject it with an error. And so if we just pass promises to consumers of our API, they can't reject or resolve these promises. They can only have functionality happen when the promise is rejected or resolved. But if we use deferred, we can resolve and reject as our API requires. So you can think of promises like a public API to promise-based code, and deferred's like the private API that reflects what the public API should do. Okay, hopefully that explains that sufficiently. Also, when you're using coroutines, you'll see I've got here done, and I think I had that in the test code that we wrote earlier as well. Done. Now, it's a bit of a workaround, but promises, you're able to have long chains of then functions on promises so that you can execute multiple things. And you can have long chains of catch functions so that you can react to many different kinds of events. But if you have a coroutine like this and you don't call done, then it's possible that errors that happen with the code inside here don't get bubbled up in a way that you can catch as part of the promise interface. So when you do coroutines, and I'm not saying go out and look for a reason to use coroutines, I'm saying if and when you use coroutines, remember you should call the done method as a way of wrapping things up. And I didn't understand this before Stephen explained it to me earlier, but done is just a way to say, okay, take any errors that happen inside here, any uncaught errors, and run them through Icicle in a way that we can catch them, that they can be reported. I'll give you another example of this. Let's take this done out, just to show you what's going on. Let's take this done out, and let's mess up our get implementation. Let's just say return broken. Okay. Now when we run this, when we run this, we're going to have two broken tests, but they're not the broken tests you think. In fact, I'm even going to comment them out so that you don't, so that it's absolutely clear what's going on. So now we only have this one test that's visible, right? And if we run this again, we're going to get one test, one assertion. But this doesn't make sense because we're asserting null, and we're yielding. Yes, I will explain, KDEX. We're yielding get anything, and this should return null according to our test. But it returns broken. pretty weird. In fact, let's make it even more obvious what's happening here. Let's say deferred resolve with an impossible value. Wow, isn't spelled right. Deferred resolve an impossible value. Run this again. One test, one assertion. This is obviously the wrong code. It's returning the right kind of promise stuff, but this value shouldn't be here. This should be a null value because that's what we're returning here. However, when we add done back in here, there we get our exception. Because an impossible value isn't null. That's because the way that Icicle is handling this, it is containing the exceptions that are thrown here, and we're not handling them explicitly, but when we call done, it wraps those up. It says, okay, these exceptions weren't handled, so rethrow them. That's what done does. So, okay, those two things just to recap. I forgot what the first is. But the second is when you do coroutines, use the done function afterwards, just to make sure that you're not throwing exceptions that you're not catching. Yes. Yes, that's a good answer. And coroutine's just that. I'll do a separate thing on generators if people are still keen about that. Anyway, that's all I have to show you. Are there any questions about this stuff? About the stuff I showed you tonight? Deferreds and promises and generally making a module for Icicle? Questions, anyone? With a delay? Okay. I think I'll wrap up there. Thank you very much for hanging around, and hopefully this was interesting. Perhaps you learned something. I really had a lot of fun doing this initially, and I had a lot of fun explaining what I did now again. I think it's super valuable to learn how we can use promises and how we can structure code to use them so that we can build asynchronous stuff for libraries like Icicle, for applications that we may have. Because we're really the ones that are going to be building the ecosystem around Icicle and around AIM-PHP and around React-PHP, so you better know how to do that. If you have questions, ask me on Twitter at assertchris. If you want to see more of these streams, then follow me on Twitch and you'll get email notifications of that stuff. And also feel free to tweet at me about, or say in chat, about topics you want me to stream about, because this is really a thing for you, not that much for me. So yeah, I think that's it. Thank you very much for being here. I'm gonna go. So